Hi, my name is Boerdijk, and we present self-supervised object in gripper segmentation from robotic motions. In this work, our aim is to derive segmentation masks of any grasped object in a robotic gripper by observing motion of manipulator and object in front of static background. The obtained object masks can serve as training data for neural networks on tasks like semantic or instance segmentation, and even yield watertight 3D object models with photogrammetric 3D reconstruction. In our framework, we first learn a visible robot arm representation. To this end, we employ a light flow net, a convolutional optical flow estimator, to estimate motion between two consecutive frames. By applying an Otsu threshold on the flow magnitude, we obtain a binary segmentation mask of the manipulator. We derive corresponding masks of the gripper by opening and closing it at static robot arm position. With these annotations, we generate training data by pasting robot arms on Microsoft CoCo images. Note that in contrast to previous work, we do not incorporate testing backgrounds into these images. We further paste occluder objects at the gripper's position to emulate the presence of a grasped object. With this self-supervised generated training data, we learn to segment a visible robot arm from static frames. During inference, we can directly segment unknown grasped objects from the manipulator. Thresholded optical flow again yields all moving foreground, and our trained robot arm segmentation network identifies the manipulator. Hence, everything in motion and not identified as robot arm is denoted as object. As the recorded object masks serve as training data for semantic or instance segmentation, or even 3D reconstruction, it is important to generate as diverse object views as possible. Even though we do not assume that the object camera transformation is known, we can still produce nearly equally distributed end effector rotations using Fibonacci sampling. For our framework, this sampling strategy is superior to, for example, kinesthetic teaching, where poses could be biased to specific views. In contrast to previous work, we rely on single RGB camera streams only. We do not use 3D robot or object models for segmentation. A major advantage of our method is the independence of precise robot camera calibration. We merely expect the robot to move inside the camera frame, and all parts of the object should be visible during recording. These constraints can be satisfied quite effortless with approximate knowledge about the robot's motion in the world coordinate frame, and by placing the camera loosely pointing towards the robot. To show the effectiveness of our method, we record a subset of objects of the YCP video dataset with the aforementioned procedure and manually annotate 15%. We compare to various baselines, such as binary change detection or direct object agnostic segmentation, where we attempt to segment manipulator and object from a single static frame. Our method performs superior to these baselines, and we outperform a recent work which benefits from camera calibration, additional depth data, and manipulator key point registration in the image plane at time of our research. Furthermore, we show that our approach is not constrained on strict object rigidity and successfully segments deformable objects. The automatically generated masks can be used for downstream tasks like semantic or instance segmentation, and for text-rich objects we can even perform photogrammetric 3D reconstruction to produce watertight 3D volumes. To further automate our method, we carry out a simple top-down grasping study. All objects but one are directly graspable with this approach, and for all but two, the robot is able to successfully regrasp them after placing. This presents a simple way of even further reducing human intervention in our pipeline. We further show that many distinct views are indeed beneficial for the generalization capability for semantic segmentation in our tabletop setting, which also underlines the effectiveness of our Fibonacci sampling strategy. We have presented a framework to automatically generate unseen object segmentation masks through robotic interactions. Our optical flow-based approach requires little prior knowledge and poses few constraints on the setup. The generated labels are well suited for various downstream tasks. For further details, please refer to our paper. Thank you for your attention.